So looking at our warm-up really quickly, who can tell me what the measure of x would be based on the arc they've given us? Marquise? 55. Remember, in scribed, you would divide by 2 to get x equals 55, half of 110. Okay, the next one we have a triangle. First of all, let's do triangle sum. What would my top angle be? What would my top angle be? 60. And then now it should be easy. These are all just a bunch of inscribed angles. We just need to take the angle and multiply by 2. So 50 times 2 will get me 100. 60 times 2 will get me 120. And 70 times 2 will get me 140. All inscribed. All right, so below I have all of the formulas, which I am going to give you on your quiz on Friday. So I'll give you a formula, this little formula sheet that has, it'll look just like this. Actually, it won't have the picture. It'll just have the type and the formula. But you'll want to jot these down so that you have them for your homework. So we learned the first two already. Central angles, remember, are equal to the arc. So the angle will equal the arc. In the inscribed angle, we know that the angle will equal the arc divided by 2, or 1/2 times the arc. And then I'm going to write another formula in there too, because remember, sometimes you're going to find the arc, and to find the arc, you'll double the angle. So that'll be 2 times the angle. So those were the ones we learned on Friday. Today we're going to see 3 other ones, and that's an on angle. An on angle is one that is, the vertex is located on the circle. It's not inscribed, however, although the formula is the same, but these will usually be by a tangent and a chord intersecting. So it won't actually have that inscribed piece where we have 2 chords. So the formula for this is actually the same as the last one. So the angle will be equal to the arc divided by 2. And when I say the arc, I'm talking about the intercepted arc, which would be, for example, angle 1. The intercepted portion of the arc, make this as small as possible, will be this little part. If I was talking about angle 2, the inscribed arc would be this whole thing. So it's just kind of where the sides of the angles start and end along that circle. And then, of course, we can also flip this around and say that the arc is equal to twice the angle. And then our last two are inside and outside. Okay, when I say inside, I mean not central, but the vertex of the angle is located inside the circle somewhere. So, for example, angle 1 would be an inside angle. Notice the angle 1 and angle 1 are what type? Vertical angles. Okay, so you will have congruent vertical angles. So to find the measure of the inside arc, you're going to, or excuse, inside angle, what you're going to do is you're going to average the 2 arcs together. So this will be equal to arc plus arc and divide it by 2. Now when I'm saying arc plus arc, it's the 2 arcs that are intersected, because we know that angle 1 would be congruent to itself. So it would be arc AD plus arc BC, and then divide by 2. So you're averaging those together to find the measure. Now if you're finding angle 2, you would add these 2 arcs and divide by 2 to find that central angle, that inside angle. Last type is if we have an outside, and again this is talking about the vertex of the angle lying outside. And for this one, what we're going to do is we're actually going to subtract the arcs and then divide by 2. And I'm just going to write, you're going to take the big arc minus the small arc and divide it by 2. So that you don't get a negative angle. So for the first instance, you would take this arc, DC, minus this arc, DA, and then you would divide by 2. This one would be arc DC over BA, and this one would be this whole thing. minus this little piece, and then dividing it by 2. So all the questions today are going to be picture problems, and you have to first identify what type of angle you have, and then choose the appropriate formula. Sometimes you will have to do some problem solving, like subtracting from 360 or 180 or something. All right, so first of all, what type of angle do we have here? Central, inscribed, inside, outside, or on? Marquise? Inside. Okay, so the formula for inside is that the angle is equal to the arc plus the arc divided by 2. So the angle is the variable x this time. They could actually give you this and ask you to find one of the arcs. So just be aware. And then our arcs are 46 and 90. Those would be the intercepted arcs, knowing that these are both x degrees. You'll just add those and divide them, and we'll get 68 degrees. What type of angle do we see in number 2? And if you're not volunteering, because Marquise is really the only one today, I'm going to just call on you, so be prepared. What type of angle is number 2? Luke? Outside. The vertex lies outside. So the formula for that is that, and if you want, you can abbreviate this with an angle symbol instead of having to write the word angle every time. So angle equals arc minus arc divided by 2. Now be careful. This time the angle is not unknown. It's known. The angle is 20. So 20 is going in on the left-hand side. We have our big arc minus our small arc, which would be 95 minus z all over 2. Now we have to use algebra to solve. How would I solve for z? That's the first thing I would have to do. Marquise? Yes, I see division of 2. I'm going to undo division with multiplication. We'll get 40 equals 95 minus z. And then it's up to you how you want to do it. If you want to add z and subtract 40, if you want to subtract 95 and then divide by a -1, it's up to you. But you'll get -55 is equal to negative z, and then we divide by -1 to get z is equal to 55 degrees. So again, really important for you to actually sit there and think what type of angle is it before you start, because if you pick the wrong formula, you're kind of in trouble. Kale, what do we think? Number 3, what type of angle is that? Outside. Outside, good. So that's our angle equals arc minus arc divided by 2. Some of them are going to be as simple as plugging into a formula. Some of them you'll have to actually problem solve to figure out what to plug in the formula. These first 2 on the back are pretty easy. So the angle, and again, if you trace it, it's going to give you the arcs that are intercepted. It has 2 arcs that are being intercepted. So we take the bigger one, 160, we subtract the smaller one, 68, and we divide by 2. X is the angle itself. Should get 46 degrees. See if you can try 4 on your own, and then 5 we're going to do together because it does number 4. Abby, what'd you get? 50, very good. We should have done that. Our angle equals our arc minus our arc divided by 2, and 100 divided by 2 is 50. Perfect. All right, now number 5 is also an outside. This is our last, well, almost our last outside example. So again, we have our angle equals arc minus arc divided by 2. Angle is x. Here's our problem. We don't know what the second arc is. We know that the smaller arc is 120. we don't know what the bigger arc is. Or do we? Brett? It's 240. How'd you find that?
360 minus 1.
Good. You can use circle sum 360 and subtract the arc that you were given to find out the other arc, which is 240. So even though it looks like this line touches at like a segment, it really only touches at one exact point. These are two tangents. If you remember our vocab from Friday. Tangent just like grazes the circle at one exact point and then keeps going. Even though when we look at it here, it looks like it touches like at that whole part, it really only touches at one point. Okay, so you can subtract that. So we'll have our 240 minus 120 divided by 2, and we should get 60 degrees. 120 divided by 2. All right, example 6, what type of angle is this? You need to look back at the front. Yes, we should. No?
An on angle.
Good, this is an on angle. An on angle acts like an inscribed angle, it just happens to not have two chords. It has a tangent and a chord being intersected. So the angle is still equal to the arc divided by 2. Now the arc is whatever is intercepted, which is the given part, which is lucky for us. That's our 246. And we'll get our 123 for W. Sometimes they won't give you the arc though. So if they don't give you this part and they give you this part, you can subtract from 360 to get the arc you need and then divide by 2. Or you could take this arc and divide it by 2, and then you could use a linear pair to find out what W is also. All right, so we have two different types of angles in this one. We should notice that we have an outside angle here. And we have an on angle here. So we're going to use two separate formulas. Which one do you want to do first? The outside or the on? The on. The on is actually going to be the harder one to do first. On's formula is arc divided by 2. Now the problem is we don't know that part of the arc. We actually can't find it yet without finding the x because we don't know that whole thing. Justin? We still need to find out what x is first. Yeah, oh yeah, and then we can do that, absolutely. So we do need to do the outside one first, apparently. Sometimes it doesn't matter. In this case, we don't have enough information to do the on angle first. So let's do the outside angle first, which is arc minus arc divided by 2. Be careful what you plug in. We actually are given the outside angle is 50. So this is going in on the left. 50 equals arc minus arc, which would be 160 minus x, divided by 2. Again, use your algebra to solve for x, so we'll multiply by 2 to get 100. And then we will subtract 160 to get negative 60 equals negative x, therefore x equals 60. Now put that back in your picture. To find our on angle, we need to know how big this portion of the arc is, which we can find now that we know the other two pieces. We can take 360, subtract 160, and 60 to find out the remaining portion of the arc, which will get us I was right, 60, which will get me 150. Is this portion right here. Oh, it's 140. Yeah, it's 140. Sorry. And then we'll plug that into our on formula. And that value is y. So we'll get y is equal to 7. All right, saving the best for last. The only thing that makes this hard is that we don't know either of the arcs, so that's where we're going to come into our problem. You guys are clearly identifying the outside as outside. So we have angle equals arc minus arc divided by 2. Problem is we don't know either arc. We don't know the big one, and we don't know the little one. We do know the angle. 40 is going to go in the long line. If we know that this arc is x, what expression could we use to represent this arc? When I say expression, something that's addition and subtraction in an accent. Joey?
360 minus x.
Yes, so you need to define an expression. 360 minus x would be this arc. Then we can plug into our formula. So the big arc is 360 minus x. Minus the little arc, which is x. Just like we normally take, 240 minus 120, we just now have an expression minus an expression, all over 2. Solve using algebra. So multiply by 2 on both sides. We'll get 80 equals 360 minus x. Let me just go ahead and simplify. That'll be minus 2x. And then you just solve. Subtract and divide. And we'll divide to get x is 140. If you wanted to, you could plug 140 back in, and then you could check and verify that it does actually, whenever you take the numbers, add and subtract and divide to get you what you want.